Okay, so the last thing I want to talk to you about on this particular section of concepts is balancing chemical equations. Okay, that's why, except for this, little bit of week 6 and a little bit of week 7, I would, you would agree with me, we've kept math to very minimum in this class. But again, that math that we learned is very essential to a lot of pre-professional exams that you might take. All right, let's start with the basic examples. There's really not much of a philosophy here. We're just going to get started on this. So let's say I give you this reaction right here. Okay. Don't worry about the arrow. That's a double-headed reaction. But for now, let's just focus only on the actual species that are contained in this reaction. Right? So you got nitrogen, you got hydrogen, you got ammonia. Okay? You don't need to remember the names as well. But my tip when you want to balance equation is write out what species you have on one side, and then write out what you have on the other side. And then when you balance them, balance hydrogen always the last. Okay? When you finish balancing everything else, you will see that hydrogen normally will be much easier to work with than if you start with hydrogen. For simple equations like these, it really doesn't matter, but I do want to drive the point across that when I give you something a little longer than this one, or something with more species than just 2 kinds, then I highly recommend you keep hydrogen for the last. All right, so let's work out what we have on this side. We have 2 nitrogens, right? Because 2 hydrogens. Then on this side, we have 1 nitrogen and 3 hydrogens, right? As I said, always start with any element that's not hydrogen first. And if there's oxygen, then the sequence is any other element, okay? And then followed by oxygen and then hydrogen. Okay, this sequence I personally have found over the years has helped me, and also has helped a lot of my students. So always work out everybody else and then come to oxygen and then solve for hydrogen. Okay, in this case we don't have oxygen, but we'll definitely look at ones with oxygens as well. So we have 2 nitrogens on this side, we have 1 nitrogen on this side, right? So where you see the nitrogen, you're going to put a 2. Not here. I can see that you're going to do that. Okay, just put it in the front. You cannot add a subscript into a molecule. Okay, that's the person's first last name. Okay, you cannot insert a middle name if he or she does not want it. And you putting a 2 there is you telling that person, have a middle name. Even though the person refuses, no, I don't want a middle name, you're telling him or her, oh, you should have a middle name, and you forcefully put that 2 in there. That's the best analogy I can give. Never put any numbers you balance as a subscript, all right? That's like forcefully telling somebody at a table to eat something, or forcefully telling them, would you like a middle name? Okay, so that's kind of what is happening. So now if you see, when you finish correcting that element, okay, what you need to do is, let's get a different color. Now if you notice, the nitrogen has become 2. We now have 2. So I always do this format because, again, you're not going to do 20 different balancing equations on a given test. You only got 1. So you can invest that 1 little time for that 1 little problem, okay? So you're finished with the nitrogens now. Now if you notice in the process, well, when you add a 2 in the front, it's just not for the nitrogen, it's for the entire molecule. Now what you have done is, now you got to multiply the 2 into the 3. So instead of having 3 hydrogens, now you have 6 hydrogens to work with. Okay, now you have 2 here. How can I make 6 into a 2 into a 6? Well, if I multiply by 3. So I go put the 3 here. Now if I notice, I have 6 hydrogens here and I have 6 hydrogens here. You don't put a check mark until you got that down, and that's it. That's a perfectly balanced chemical equation. Okay, let's look at a few other examples. Let's do this. Al plus, I'm just going to start with the pink here and then maybe venture in Al3FeN2 going to Aln plus Fe. Say this is the reaction I give you. Well, in this case, there's no oxygens, there's no hydrogens. So, you know, it really doesn't matter which one you pick and which one you solve first. All right, so I'm gonna, you know, write down first exactly what I have on the left side. I have 1 aluminum, 3 iron pieces, and 2 nitrogen pieces. On this side, I have 1 aluminum, 1 nitrogen, and 1 iron, right? Now, the aluminum is 1 to 1, so it's not something I would really worry about because by the time you finish everybody else, it would automatically work itself out. What I do need to focus on, I can now pick either iron or nitrogen to start with. I guess I'll start with the way it's written. I'm going to start with the iron. So I got 3 irons on this side. I got 1. So if I multiply this by a 3, right, that means now I will have 3 irons, right? Again, so you don't go put it here. That's like giving the person, in this case, a last name that they don't want, right? So go put it in the front. So now we can cancel this out and now we have 3 irons. So iron is done. Okay. Sometimes what you've just taken care of might change when you change something else. So it's a cat and mouse game. You got to go back and keep fixing it until everybody looks the same. Now iron's fixed. We got 2 nitrogens here and we got 1 nitrogen here. So if I multiply this by 2, now I have 2 nitrogens, right? So that means I go put 2 here. Now this is exactly what I was saying. I have changed the nitrogens to 2, but then in the process, so the nitrogen's fixed, so we can put a check mark. And then the aluminum is now 2Al. You don't put a check mark until you actually confirm that they are the same. Well, there's 1 here, there's 2 here. So I multiply this by 2. So I put a 2 here. And now you see that 3 iron, 2 nitrogen, and then you also have 2 aluminum. And now we can officially check it off, and then we can say that's essentially is a completely balanced chemical equation, right? Okay, so let's go get maybe another one that's a little tricky. So KBr plus FeOH3. Okay, let me actually delete this screen and get a new screen in. Okay, let's say I give you something like this. So far what we've looked at is just basically, you know, just skimming the surface, okay? Let's say I give you this. Again, this is very easy, so that's why I reserved it for the very, very last thing. So again, first you want to write down what are the given informations that I have. And this is where, you know, things can go wrong, all right? If you really don't want to miss that point or two, whatever that question is worth on a balancing, because, you know, this is like, you know, peanuts, you know, you just go through it so quickly that you need more. So there's no way you can really be, you know, having trouble with balancing equations. So I have 1 potassium, 1 bromine, 1 iron, right? This 3 is only for the O and the hydrogen, not for the iron, okay? So this is like your sir or, you know, junior, senior, whatever that is you put behind your name. That's only for this, okay? That's not for, you know, everybody in the class, okay? So this is just you with a senior or junior or 3 or 4 or 5 behind your name. That's only for you, okay? Think of you within this little bracket. This is everybody else in the classroom, okay? So this is only for you. So we have 3 oxygens and 3 hydrogens. Okay, so on the same account here, we have 1 K, 1 oxygen, 1 hydrogen, 1 iron, and 3 Br. As I said, if possible, work everybody else, and then when you finish, go to oxygen, and then when you finish oxygen, go to hydrogen. Guess what? By the time hydrogen would have already self-worked itself out, and that's why I'm saying that, because sometimes starting with hydrogen can lead to more cat and mouse game. You would eventually finish it, but again, it's going to take a lot longer. All right, so 1 potassium, 1 potassium. I'm not even going to bother with it because it's exactly the same thing. And then 1 iron, 1 iron, that's also the same, so we don't need to focus on it right away. Well, there's 1 Br here, and there's 3 Br here. So that's where I want to start. So there's 1 and there's 3, so this has to become 3. So I multiplied this by 3, so now I get 3 Br, and you go put the 3 here. Okay, so now we can say that they are done. Right, now what have we done in the process? Now that's what I think will eventually get to people, as they forget that you made change to the K as well. Now we have 3 Ks. Okay, and we have 1 K here, so we put 3, we multiplied this by 3, and then now what happens here is we have 3K, right? Good. Actually, yeah, from now I'll change the colors. Okay, so I am done with my potassium. So let me go get my blue again. Now what have we done in the process? You focus on first where you finish last. Okay, so in the process of me adjusting for potassium, I definitely did change my oxygen count. Now oxygen is 3 oxygens, and I now have 3 hydrogens, right? We have so far not disturbed the iron, so that seems to be okay. So I guess we have to now go for the oxygen or the iron, because we did not really affect our, well, I forgot to cancel this out. So we have to now work with our oxygen, right? So there's 3 here, there's 3 here. Well, seem like that's worked out. There's 3 hydrogens here, there's 3 hydrogens here. Seems like that's also worked out, which means iron's worked out itself. That's it. This is your balanced chemical equation. Now, because I didn't teach you the various types of chemical reactions, I'm teaching you this. I think this is much more important than just knowing the name of the chemical reaction itself, right? So let's look at one more problem before we can call this concept a quit. Okay, so let me get, perhaps I think I'm gonna just get this instead of writing it down. So okay. All right, so I'm gonna wrap this balancing equation session with this last compound in front of you, right? And you know the drill. Well, since we already have an equation in place and everything's there, let's go ahead and write it down. We have 1 chromium. There's 2 only for this whatever's in the bracket. So there's 2 nitrogens. Okay. There's 4 oxygens. Right? First, write everything as it appears, and then we can go club them if we have to. Again, we have 2 nitrogens. Keep them separate for now. 2 nitrogens, 6 hydrogens. Okay, 1 sulfur. You can work it separately as well, because that's even easier. So let's do that method here. 4 oxygens. Okay. On this side, we have, let's call this 2 tiers. above and below. So we have 1 chromium, 1 sulfur, 4 oxygen. Okay, I think I've made a mistake here. This should have been 8 hydrogens. Okay, because there's 4 times 2. Okay, so that's your upper tier. Let's get our bottom tier. So it's 1 nitrogen. All right, actually there's 2 in there. 2 nitrogens, 4 hydrogens, and 2 oxygens. As I said, if you have a complex array of elements in your equation, then work everybody else, then go to oxygen, then go to hydrogen. Okay, so I look at chromium, that's first on the list. Well, they're both 1 to 1, so I don't think I have to worry about it too much at this point. Let's go to the nitrogen here, right? There's 2 nitrogens here, right? And then how many do I have? Nothing on here, and then there's also 2 nitrogens on this side, right? But I have a total of how many, right? I have a total of 4, right? 2 here and 2 here, right? Because the nitrogens here are separate, but they're clubbed together here. So you have to combine this information. So now we have 4 on this side, we have 2 on this side. So let's go get a different pen. So we can multiply this by 2 to get it to 4 nitrogens. So we can now put 2 here. Okay, now our nitrogens are tallied, so we can just check it off. What have we done doing that on this side, at least the bottom tier? We have changed our hydrogens to 8, right? And we have changed our oxygens to 2 times 2 is 4, right? Now let's go look at on this side. Okay, now let's look at perhaps the sulfur. Okay, there's 1 sulfur here, and there's also 1 sulfur here. So that's already looking good. So we don't need to worry about it too much. And unless we go change something and something else changes, then we have to fix it. But as it is, we're good. And then if you look on this side, everybody else is matching. 4 oxygen, 4 oxygen. Oh no, yeah, 4 oxygen, 4 oxygen, 4 oxygen, 4 oxygen, 8 hydrogen. Everybody else is balanced. So this is the balanced equation. What do I put in areas that are vacant? Just write 1, because 1 is a term, you know, just like, you know, when you don't know what to do, just put 1, and that's it. And I have given you, I mean, this is the complex I could find. I could find more, but again, I don't want to do a balancing equation workshop where we learn everything about balancing equation. We just need to know the concept. And I have worked, I think, 4 different problems with 4 different vantage points. Okay, and that's all you really need to know to complete your week 7 material. So that's pretty much all I have to say. So stay tuned. Bye.